Question 11. The speedboat is 100 kilometers west of a trawler. The trawler is traveling south at 8 kilometers an hour. So south at 8 kilometers an hour, so no I. So the velocity of the trawler, 0I. It's going down, so it's minus HA. The speedboat is traveling at 20 kilometers an hour, 30 degrees south of east. So just south of east. So we're going in a positive, negative direction. So the velocity of the speedboat is 20 by the cos of 30 in the I direction, minus 20 sine 30 in the J direction. That's going to give me 20 by root 3 over 2, so 10 root 3 in the I direction, minus 20 by a half, minus 10 in the J direction. We're asked to find the velocity of the speedboat relative to the trawler. So the velocity of speedboat relative to the trawler, velocity of speedboat minus velocity of the trawler, which is equal to 10 root 3 minus 0, so just 10 root 3 in the I direction. And we have minus 10j minus hj, so that's going to give me minus 2j. Minus 10j plus hj is minus 2 in the j direction. Doing a quick diagram of this. S is 100 kilometers west of T. We have S and we have T. The velocity of S relative to T, positive, negative, so it's going down in this direction. And we have our shortest distance here. We call it X. We have our angle theta. So we put our 100 in, and if we use T as the origin and put my y-axis in, we can see here that the tan of theta is equal to the opposite, which is the y2 over the adjacent, which is my x value, or my I value in this case, which is 10 root 3. So finding the inverse tan. The inverse tan we can simplify to 1 over 5 root 3 is equal to theta. So theta is equal to, works out to be 6.59 to 2 decimals degrees, and that is in a southeasterly direction, southeasterly or south of east. The magnitude of this, the magnitude of the velocity of S relative to T is equal to the square root of, we have a 10 root 3 to be squared, and we have a 2 to be squared. So that's going to give me 100 by 3, 304, the square root of 304 here. And the square root of 304 is 17.44 kilometers an hour. And we are also asked for the shortest distance. Okay, let's look at the shortest distance. So we have our x, I'll just color it in red. So we have the sine of theta is equal to O, which is x over h, in this case is 100. So 100 by the sine of theta, and theta is 6.59 degrees, is going to be my shortest distance. So this works out to be 11.47 kilometers. What's next? 2 hours before the shortest distance. Okay, 2 hours along here before the shortest distance is reached. So we just need to work out how far it's traveled in 2 hours. It looks like it's going to be 32. No, I'm using the shortest distance at the relative speed, 17.44 by 2. 34.88. So if we take this triangle out, we can see that this is 34.88 here. X is the distance they are apart, and we have the two straight sides. We're looking for the diagonal, so 2 hours before is equal to the square root of 34.88 to be squared plus the shortest distance of 11.47 to be squared. And this works out to be 36.72 kilometers. That's all they're asking for here. That's the end of question 11. Okay, we go on and look at question 12. Question 12. A is 100 meters west of B, or Adam and Barbara. A is traveling at 10 meters a second, 30 degrees north of east. So the velocity of A, just do a quick sketch, north of east is positive, positive. So it's going to be 10 cos 30 in the I direction plus 10 sine 30 in the J direction. So that's 10 by root 3 over 2, which is 5 root 3. And 10 by a half, it's going to be 5 in the J direction, not the I, in the J. Velocity of B, north of 3 meters a second, so 0I plus 3J. The velocity of A relative to B is part 1. It's equal to the velocity of A minus the velocity of B, which is equal to 5 root 3 minus 0, so just 5 root 3 in the I direction, and 5 minus 3 in the J direction is plus 2 in the J direction. The magnitude of the velocity of A relative to B is the square root of 5 root 3 to be squared plus 2 squared. That's going to give 25 by 3, 75 plus 4 is 79, the square root of 79. I'll just leave it in that format for now with on my calculator. And then the angle, which I'll have to get my calculator for, is the inverse tan, if we look at theta, of 2 over 5 root 3. So theta works out to be 13 degrees. The shortest distance, okay, we'll do a little sketch here. The velocity of A relative to B is positive, positive. We have our west or east of each other, depending on the direction you go in. A is 100 meters west of B. AB. Velocity of A relative to B is in a positive, positive direction. And here is my shortest distance here. X, my right angle, turn this backwards, my right angle, 100 meters. And we have our angle theta. So the sine of theta is equal to x over 100. So 100 by the sine of 13 is my shortest distance, giving x to be 22.5 meters. The time interval when they're within 30 meters of one another. Okay, I'll just extend this line along a little bit and change colors. So when they're within 30, so this has to be 30 from here to here, and this has to be 30 from here to here. So I need to get this side, double it. So I'm looking for one of the straight sides, and you can see my right angle 30 is opposite it. So the square root of 30 squared minus x, which was 22.5, to be squared, gives me 19.843 meters. If I multiply that by 2, 39.686. So we're looking at relative distance or relative speed. It's going to give me the time interval. So this time interval, I have my relative distance 39.686. My relative speed was root 79. I didn't simplify it, so we're going to have 39.686 divided by the square root of 79, which is equal to 4.47 seconds. Okay, on to the last question, 13 in this section before moving on to the next one. Question 13, at 12 noon, P is 75 kilometers due west of Q. P is traveling southeast at 50 kilometers an hour. So let's just look at that. Southeast is 45 degrees. Positive, negative. So the velocity of P, 50 cos 45 in the I direction minus 50 sine 45 in the J direction. 50 by 1 over root 2 is going to be 50 by root 2 over 2, so 25 root 2 in the I direction minus 25 root 2 in the j direction. The velocity of q, due south at 30 kilometers an hour, so due south is negative j, so equals 0y minus 30 in the j direction. We're asked to find the velocity of q relative to p, the magnitude and the direction. So the velocity of q minus the velocity of p, which is equal to 25 root 2 minus 0, so just 25 root 2 in the I direction, and minus 25 root 2 minus 30 in the j direction, minus, I'll just bring them together. So it's going to be minus 25 root 2 plus 30, which is actually going to give me plus 5.36 if I do it on a calculator. 25 root 2, sorry, I've done it the wrong way, it's q relative to p, isn't it? Q relative to p, so it should be q take away p, so I should have a minus here. There should be a minus here, I did the other side the right way, so that's minus 35.36 in the I direction. And did I do this one right? It's going to be the minus 30 plus the 35.36. This is going to be a plus with the minus sign, so that is going to give me plus. That's a minus and a plus 5.36 in the j direction. Probably by taking shortcuts like this lead to mistakes, as you can see here. Don't do it. I'm just getting to the end of my tether. Okay, so that's the velocity q relative to p. So let's just do a quick sketch, and then we'll write down their magnitude and direction. 75 kilometers. Why am I writing 72? Because I'm tired. 75 kilometers. P is west of Q. P and Q, I'm just about getting my east and west correct. And it's a negative positive. Velocity of Q relative to P is negative positive, which is down in this direction here. No, it's not. It's negative positive. That's negative, negative. Negative positive is up in this direction here. So I have my theta. We take P as the origin. You can see here that my right angle opposite the tan of theta is equal to my J, 5.36 divided by my X, which is 35.36 to give me the angle, which is 8.62 degrees. And that's in the direction north of west, north of west, rather than northwest being 45 degrees. And so the magnitude of the velocity of Q relative to P is the square root of these guys, 35.36 to be squared plus 5.36 to be squared, and that gives me 35.76 kilometers an hour. We look at the shortest distance. We have my angle in there, we call it X, so the sine of theta is equal to X over H being opposite the right angle, 75. So 75 sine theta, 70, that's a 5 sine 8.62 is equal to my shortest distance. So my shortest distance is 11.24 kilometers. And then we're asked, visibility is 40 kilometers. Show 1 p.m. is the time they will come into vision, and when will they lose sight of each other again? Okay, let's sketch another diagram here. Q and P. It's going in this direction. Got my shortest distance, and they're going to be in range for 40 kilometers. So this is 40, and this one is 40. So we have my shortest distance is 11.24. So I can get my, I'll call it Y and Y here. So we're looking for one of the straight sides. So y is equal to the square root of 40 squared minus 11.24 squared. Y is equal to 38.39. So 2y is double that, 76.78 kilometers. That's when they're in range. The relative speed up here is 35.76. So if we do the relative distance divided by the relative speed, that's going to be 76.78 divided by 35.76. That's going to give me 2.15 hours, which is 2 hours and 9 minutes. That's when they're in range, but we're asked, show that they come into range at 1 p.m., which is here. And when will they lose sight of each other again, which is here. So I need this distance here. Now we have a 75. We have y, so I just missed an x here. So let me just, in this triangle, calculate what y plus x is. So I'll just do it on its own first. So we have the right angle in here. So 75 is the diagonal. So the square root of 75 squared minus 11.24 squared is equal to x plus y. Now we have y is 38.39. So the square root of 75 squared minus 11.24 squared, and that's going to give me 74.15 as the washing machine is about to take off. That's equal to x plus y, which is x plus 38.39. So 74.15 minus 38.39 is that distance x that this ship has to travel before coming into vision. So what's 74.15 minus 38.39? That's 35.76, which is also the relative speed. So you can see here it's going to take an hour. So relative distance over relative speed is equal to 35.76. That was the distance we just got, and the speed 35.76, which is equal to 1 hour. Therefore 1 p.m. 12 noon plus 1 hour, therefore 1 p.m. into vision, and they're in vision for 2 hours 9 minutes, so therefore 3:09 they lose sight of each other. Did they ask us, did they give us that? No, just when will they? That's that question complete, and this exercise 4b complete. Let's go on and look at 4c.